Okay, good morning. Happy Thursday. This is just a little video to kind of explain the notes that I posted. So this table here shows how your value changes as your exponents get smaller and smaller. So if you notice here, as the exponents are getting smaller, when you move to the right, jump, 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 each time you're dividing by the base, by the factor. And a big reminder that anytime you have a value to the 0 power, it's 1, because essentially you're dividing that number by itself. So, and it says this here in the words, but people usually don't read this part because words are not as exciting as images and colors. So here's another table that kind of explains it. So starting from here, 3 to the second power being 3 times 3, we know how numbers change when the exponents get bigger. We just keep multiplying and multiplying and multiplying the base by however many times the power tells us to. But what happens when that value gets smaller? So you can see, so 3 to the first power is 3, 3 to the 0 power is 1. So what I want you to notice is that each of these negative exponents, they're all written as fractions. So anytime you have a negative exponent, you're always going to have it written as a fraction, and it is always going to have 1 as the denominator. So if you notice, for 3 to the negative first power, you have 1 over what 3 to the first power would be. And for 3 to the negative second power, you have 1 over what 3 to the second power would be, which is 9. 3 to the negative third power, 1 over what 3 to the third power would be, which is 27. So here's some examples. Those are really fun to make and really satisfying. A little reminder about the 0 power. The big thing is you cannot have 0 to the 0 power. That's not a thing. You can't do that. More examples of the 0 power. All right. So these examples might help you with your homework. So for example, 8 to the negative first power would be 1 over, because anytime you have a negative exponent, you're going to write your answer as a fraction with 1 as your numerator. So 1 over what 8 to the first power would be, which is just 8. If you come over here, 10 to the negative fourth power, it's 1 over 10 to the fourth power, which is 10,000. Here is an example of an order of operations problem with negative exponents, because we fancy like that. So you start inside the parentheses, 8 minus 16, which is 2, and then 2 to the negative fifth power, again, 1 over, and then you have 2 to the fifth power, which is 32. Okay, so this last one looks really complicated and scary. I mean, what kind of math teacher would I be if I didn't scare you? So all the steps are spelled out, and just remember your order of operations, your PEMDAS. So I started here by simplifying 9 plus 7, which is 16. And then what I did is I took 16 to the 0 power, which is 1. And then for my next step, I cleaned up what was in here, which is negative 3 to the negative second power. So that's 1 over negative 3 times negative 3, which is positive 9. So when I cleaned up everything, got rid of all the exponents, it's 3 plus 1/9, which is just 3 and 1/9. And then you subtract 1 from that. So it's just 2 and 1/9. Okay, that's a lot, but I promise watching the videos will help.